Hey guys, today we're going to talk about the most important property of all of math. In fact, without this property, we couldn't do algebra. It's that important. So this is going to be lesson 6-6, and I'm going to call it the distributive property. Now, the first 3 slides you see are actually going to all take place on one page. Oops, that's not a very good P. Let's try that again. So there we go. Property, and today's date's going to be 2/12/19. Okay, so, and I'm just going to take my room on what I'm doing, but again, what I'm about to do on this screen should go about halfway on your first page. So what I want to do is give you a scenario of something that's going on, and then we're going to go ahead and go through and solve it. So we have 3 friends. In fact, I'm going to pause this. I'm going to write it up, and then I'm going to go ahead and, instead of wasting the time on there. And then you guys do the same thing. Pause it once you get the whole word problem out, and then start it up again. So I'll see you in just a sec. Okay, I'm back, and I do need to apologize. I'm totally stuffy. I woke up completely stuffy, eyes watering. Life goes on, okay? So here we go. 3 friends went to a baseball game. Each ticket cost $20, and all 3 friends bought a baseball hat for $15 each. Okay, so that's what I want you to go ahead and pause and write it down, and then join us back. So what we're going to do is answer 4 questions. 4 questions. We're going to look at this problem, and we're going to translate it from 2 perspectives. So first off, what does 3 times the quantity 20 plus 15 represent? So from the problem, what do those 3 numbers represent? So first off, let's think about the 3. Well, it says there were 3 friends. Okay, so that's what the 3 represents. Okay, so then what does the 20 represent? So 20, it said each ticket to the baseball game was $20. So that's the cost of a ticket to the game. Okay, and then we need to figure out what the 15 means. And the 15 talked about all 3 friends bought a baseball hat for $15 each. So that's, weird dot there, cost of a baseball hat. Okay, so question 2 would be to evaluate that. So we're going to evaluate 3 times the quantity 20 plus 15. All right, so according to order of operations, we take care of what's in the grouping symbol first, and we get 20 plus 15 is 35. So we have 3 times 35, and then we just multiply 35 times 3. We get 15, 9, and 1 is 10. So what we get is 105. So basically, what we have is $105 for those 3 friends to get into the game and then to also buy a baseball hat. Okay, so let's talk about the next group of questions. Oops, sorry, this is question 3. Yep, it can't count anymore. What does 3 times 20 plus 3 times 15 represent? Okay, and we can say, well, 3 times 20 is going to be 3 people buying $20 tickets each. So that's going to be the cost of the 3 tickets. So instead of kind of looking at individually what does one person spend and then multiply that by 3, we're now going to figure out how much it's going to cost for the tickets. And then for the other part, we've got 3 times 15. What does that mean? Well, that's 3 baseball hats. So that's the cost of the 3 hats. So what we're going to do is evaluate this statement, or this expression, excuse me. And that would be 3 times 20 plus 3 times 15. All right, so according to order of operations, we're going to do any multiplication or division as it shows up. So first I see is 3 times 20, that's 60. Next I see 3 times 15, and that's going to be 45. And 60 plus 45 is 105. So what I notice is that 3 times the quantity, 20 plus 15. So how much each person pays, the 20 plus the 15, times the 3 people. And that was exactly the same as what we would do if we wanted to figure out how much it cost for the tickets and how much it cost for the hats. And again, let's just note here that 3 shows up here, here, here. So that's going to be your major number there is showing up. We also have 20 shows up here and here. And then we've got 15 here and here. So the same numbers are represented, okay? And if you think about it, look at the operation that's happening is the same for both of them, okay? So what I've just basically shared with you is how the distributive property works. So I'm going to go to my next slide, and I'm going to add a picture. Now we have a foldable that we've already put in motion into our practice, or composition notebook, excuse me. And so this is ours on the distributive property. So let's give a definition to the distributive property. The distributive property. Oh my gosh. Terrible spelling today. Sorry about that. So what we're going to do with the distributive property is we're going to multiply an outside term. In the case of the example we had, it would be the 3. So multiply an outside term by each term in the parentheses. So that would be the 15 and the 20. So again, remember, this is getting written right underneath what was left at bottom of the last screen, where we had the 2 answers set equal to each other. So this is not a new page. This is still that same page. Okay. Now, what happens when I went from the 3 times the quantity 15 plus 20 to the 3 times 15 plus the 3 times 20? Well, number one thing, most important, parentheses disappear. Okay, now this is extraordinarily important because we're going to come across problems where inside the parentheses is a variable. So to do order of operations would be impossible unless somebody told us what the variable equaled. So let's say we had 3 times x plus 15. I can't do x plus 15. So the only thing I could do is the distributive property and multiply that 3 by the x and multiply 3 by the 15. The parentheses are gone. It's the only math that I can do. Okay, so to verify with that, we must use this parenthesis, or this property. Oh, got myself ahead there. Must use this property when variables are present. Okay, so if you see here, there's a little itty bitty baby, and it says here the distributive property allows you to multiply a sum or difference by a number. Now, what are they talking about? Right here is a sum. Notice that that is going to stay the same, but it's also saying that the sign could be a subtraction sign or a difference, right? Now we have a b on the outside, and we have an a plus a y on the inside. So what the distributive property allows me to do, it allows me to multiply the b times a, and that gives me ba, because remember, when we have two variables being multiplied, or a number and a variable being multiplied, they just butt up next to each other, and you do not see a multiplication symbol. But I'm also going to share that b to the y, and that gives me the by. Okay, so again, the distributive property allows you to multiply a sum or difference by a number. So in other words, we're going to take that number and we're going to share it with everything inside the parentheses. Now don't always think it's going to be two numbers, because you can have lots of numbers, parentheses. So when you distribute, think about a distribution center. What they do is they have a main hub, and then trucks come in and they get the product, and then they take it out to all the stores. So they're distributing it to all the stores. Now, they want everybody to sell their products, so they're going to send the same amount to everybody, right? And this is how it works, okay? So now I'm ready to go on to my second page, and we're going to practice doing the distributive property, okay? And, or actually, no, I lied. We're going to come here, and we're going to add a picture. We're going to do the inside of that foldable. Okay, so now we're going to talk about the distributive property. So on this left flap, it talks about for every real number a, b, and c, a times the quantity b plus c equals the product ab plus the product ac. So all I'm doing is sharing the a with the b and the c on the inside. The reason why it says plus is because there's a plus in your original parentheses. And then the same thing with a minus sign in there. We have a times the quantity b minus c. That's going to give me the product ab minus the product ac. Now, even if the variable is behind in the back, they have a times b and a times c. Now, I'm going to tell you, I don't like what they wrote here. I'm going to share with you what I would have written there. I still would have put it alphabetically, and I still would have written it as, oh, come on, you. Why are you being so stubborn? Oh, he doesn't like me today. Let's do it over maybe to the side. So I would say this would be AB plus AC. And this one, instead of BA minus CA, I would say AB minus AC. Okay? All right, so it says use the distributive property to simplify 34 times 102. So what we're going to do is we're going to keep the number on the outside intact. So we're not going to change it. That's what intact means. And we're going to keep 34, 34. But we are going to change the second number into the sum of values. And so the easiest way to do math is if we go into place values. So I have 100 plus a 2. Okay? Now, when I do this math and I distribute, I'm going to multiply the 34 times the 100. So this is a good way to do a mental math problem from larger numbers, is to break it down into 2 smaller problems. So we're going to get 34 times 100, and then we're going to get a plus, and then we're going to be multiplying 34 times the 2. Now, I like to draw those little arrows to remind myself what I'm supposed to be multiplying so that I don't forget about anything. That's kind of my deal. Okay, now I can do these 2 problems mentally, and we get 3,400 plus 68, and we add those together, and we get 3,468 as the final answer. Okay, so that's one way that we can use the distributive property. Let's talk about this way over here, second one. So this is an example where the number we want to distribute is in the back. It doesn't matter. We're going to multiply the 2 times the 5x. So let's do 2 times the 5x. And then notice that it says plus inside of here, right there. So we're also going to write plus. And then we're going to distribute and multiply the 2 times the 3. So it always goes the first number in this quantity and then the second number. So then we have the 2 is going to be times the 5x. Oops, sorry. So, remember, this one I couldn't have solved it any other way because I couldn't add 5x plus 3. So this is all I could do when it's algebra. So I could do 2 times 5x. Well, 2 times 5 is 10, and then I have an x. And, oh, I wrote 5x in there. See, this is when I need you guys going, Miss Rosner, you forgot something. Okay, let's try this again. This was a 3. Talk 3, and then I'd say x. Silly me. So anyway, this one, first one was 10x, and then 2 times 3 was 6. And that's as far as I can take this problem. If I don't have 2 terms that both say x, then I can't add those together. Okay, so let's look at the next one. Now I'm going to alter it, and instead of it saying negative, we're going to put a 3 there. Okay, just for our purposes. So we're going to multiply 3. Let's make him dark green. And we're going to multiply him by the 6x. And then if you notice, inside we've got, again, a plus sign. So we're going to say plus between them. And then we're going to multiply the 3 times the 4. So 3 times the 4. And then we just do whatever math we can do. So we have 3 times 6x. 3 times 6 is 18. And then we have the x's added on. And then 3 times 4 is 12. Now again, we can't do anything because I can't add something with an x to something that doesn't have an x. So again, just to remind you, we can have the problem be a little bit more complicated. So step 1 says multiply the term just outside the parentheses by every term inside. What is that? The distributive property. So that's what they're telling us to do. Oops. Distributive property. But then they talk about finish by combining like terms. So I'm going to kind of demonstrate that to you as I go through the problem. So we're going to start by multiplying 6 by everything in that first set of parentheses. So that's going to give me 6 times m. And then it says minus. So I'm going to put that in. Do a little darker one. and then we're going to multiply the 6 times the 2. So I don't have to worry about signs because I've already taken care of them. And then we're going to multiply 6 times 3n, and it said plus in front of it, so I'm going to put a plus in front. And then we're going to get 6 times 3n. Now I'm also going to make another alteration to this problem. And notice here it says minus between the two groups. Well, we're going to make it a plus sign because we're not ready to deal with the integers yet. Kind of talked about that before in the other stuff. So we're going to multiply this time 4 times each of the things inside its parentheses. Now notice it says plus in front of it, so we're going to write plus here. And then we've got 4 times m. So we have 4 times m. And then we have, let's see, another plus. And then we're going to have 4 times 1. So what we're going to look for when we combine like terms is we're going to look for anything that has the same letter or anything that has anything that's related to each other. So here's what let's just multiply out. So we get 6m, and then we have minus, and then we get just a constant 12, and then it says plus, and we have 6 times n, so that's 6n, or sorry, 6 times 3n, 18n, and then it says plus, and then we have 4 times m, and that's going to be 4m, and then it says plus, and then we have 4 times 1, and that's going to give us 4. So if you notice, I've got some color coding going on, so I'm going to kind of bring them together. So we've got 6m plus 4m, and then we're always going to use pluses in between. And then we have 18n, so I always put the variables first, and I put them in alphabetical order. M comes before n. And then I'm going to put my constants at the end. And again, I'm just going to always use a plus at this point. And then signs, when I get older and we practice more, we'll probably see we'll end up with subtraction signs, but not as far as we're concerned. Actually, we're going to make one more change. Silly me. Make everything a plus. He's a plus. He's a plus. There we go. That makes everything easier. And then we've got the 12 and the 4 that we're going to group together. So when we do the math out, we get 6m plus 4m. Well, 6 plus 4 is 10, and there's an m. And then we have 18n. And then we have 12 plus 4 is 16, and that would be the answer there. Now we're going to deal more with the combining like terms on the next day or next set of notes we take. So one more set. Now we're finally ready to do the examples I have for you. Okay. See, this is bad when my head is stuffy and it's late at night. Bad combination for me. So here's our first set of directions. Find each product mentally. Now, you need to understand when I say these directions, it doesn't mean that you don't show me anything. What you're not going to do is long multiplication. We're going to show by breaking up our numbers into smaller numbers and making the math easier. Show your steps. So first problem, we have 9 times 36. So I'm going to keep the 9, and I'm going to use parentheses, and I'm going to break 36 into 2 parts, and I'm going to look at its place values, because I'm trying to end with numbers that end in 0. So we're going to have 30 plus 6. Okay? So then I'm going to distribute, and I'll show you a different way to do it. So I'm going to multiply 9 times the 30. So these are the steps I'm referring to. And then plus 9 times the 6. Now I just do those math. That should be mental math for me at this point. So 9 times 3 is 27, but there's a 0 there. And 9 times 6 is 54. And then I just add these up. So I get a 4, a 12, carry the 1, and I get a 3. So I get 324. Okay, so that's what I mean when I say mentally. All right, another problem. Let's do 12 times, are you ready for it? Mixed number, 12 1/4. This is going to work the same way, but we're going to break it down into whole number and to fraction, okay? So we're going to have 12 times 2, and then we're going to have plus, I'm going to put this guy over here, and then 1/4. Okay, so when I distribute, I'm going to get the 12 times the 2 plus the 12 times the 1/4. So then when I get 12 times 2, I get, 24. And then I can do this if it makes it easier. 4 goes into itself once and into 12 3 times. So I get 3 times 1 over 1 times 1, which gives me a grand total of 3. And that gives me 27. I could also think of 1/4 of 12 is 3. Okay, and there's the answer. So this is how we show steps in a mental math problem. And guess what? We're going to do it with a decimal. 2 times 3.6. So we're going to have 2 times the quantity, and you got it. We're going to break it up into its whole number. Oops, forgot to change my colors. Into my whole number and into my decimal. So when I distribute, I'm going to get 2 times 3 plus, because that's what it says inside, 2 times 0.6. Now notice the difference between a multiplication dot and a decimal dot. 2 different locations, okay? So let's see what we get. We get 2 times 3 is 6. 2 times 6 is 12, but there's going to be 1 digit after the decimal point, so I get 1.2. So whole number goes with whole number. 6 plus 1 is 7, and I get 7.2 as my answer. All right, last one, or sorry, directions. And I'm sorry this is taking so long. We're going to use the distributive property. To rewrite each algebraic expression. Okay, so these are going to be short, sweet, simple, right? So we've got example 4. We have 3 times the quantity x plus 1. So the guy that's going to be on the outside is the 3. And we're going to distribute him to everything on the inside. So we're going to multiply 3 times the x, and then it says plus, and then we're going to distribute the 3 times the 1. And we get 3 times x is 3x, and 3 times 1 is 3. Nothing more I can do because those are not the same type of number. Done. And then the second one, we're going to put the guy behind. So we have x plus 8 times 5. We're going to multiply the 5 times the x. Always go back to the front. And I'm going to show you this a different way. I can use parentheses to show my multiplication. It says plus on this inside, so we're going to do plus. And then we're going to multiply 5. Oops, change my color. Let's see. 5 times the 8. So that's 5, and then again I can use those parentheses to show multiplication, times the 8. So 5 times x is 5x, and 5 times 8 is 40. I can't do anything more because 5x and 40 do not have the same variable in common. So that's all I can do. And that's it. Thanks, guys. We'll see you later.